with Mr. Fitz, and today we're going to be looking at graphing linear inequalities. And really, the only difference between an inequality and a line is that we're going to be shading an entire region. So when I'm doing an inequality, I'm talking about half a plane. And today what I'm going to be doing is a system of inequality, which means I'm going to get a half plane, but then I'm going to have another graph on top of it, and we're going to be looking at what happens. So when I click on this first graph, y is less than 5x minus 2, we can see that the computer is going to graph that for us. And it started at -2, it went up 5 over 1, and that's how it was able to make this graph. Here you can see the point. And it's shaded below because it was less than, it's a dotted line. So that's what we were doing in the last week. But the new thing about this week is you're going to have a second inequality graphed on top of it. So if I cut this one off and put this one on, another inequality of y is greater than or equal to negative x plus 2 could be shown by this graph. It starts at 2, it's going down 1 over 1, so that's a great looking graph, it's a solid line. But if I put them both together, the only place where both of them are shaded is this part up here on the right. Because this part only worked for the blue color, this part only worked for the red, but this part worked for both of them. So when I look at the solution to this particular system of inequalities, anything in this purplish region is going to work for both of those statements. Now, we could do a test point. I don't have to, but if I did 2, 2, that should work in both of these equations. So if I replace x with 2, I'd get 10 minus 2 is 8. 2 is less than 8. If I replace y and x with 2's, then I'd have 2 is greater than negative 2 plus 2. 2 is greater than or equal to 0, so they're both accurate. So I can tell when I'm looking at my graph, I can tell which section works based on, am I below the line, am I above the other line. Notice the red one, it has to be below the red line, so I shaded under this red line. And for the blue line, it says greater than or equal, so I shaded above. So I'm above the blue line and I'm under the red line at the same time. That's what gives me my answer in the purple region. If I do a second example, let's look at these two. They have the same slope, so they're going to be parallel lines. So I'm going to go under, because it's less than, under the line that starts at 1, but I'm going to be over the line that starts at -3. So if I'm under the line on top, but I'm above the line on bottom, then I'm really just talking about this middle space as a possible answer. Again, we could do test point, 0, 0 is in that middle space. So if I replaced x and y with a 0, 0 is less than or equal to 1, true. 0 is greater than or equal to -3, true. So I know that we did that one right. Now, what if they're both greater than? What if I want to be on top of both lines? Is that possible? So on the black one, we can see I've shaded above because I'm supposed to be greater than, but the other one is supposed to be greater than as well. So I'm going to shade above the second line. Therefore, if I'm going to put in an answer, I'm just going to shade in this part on top, this section, because it's with the part that's above both lines. It's above this red line, and it's above this black line. So this is the section that we would shade in. Now on the computer, they're really shading more than you have to. When you're doing these out by yourself, you're just going to shade the one section which meets both qualifications. The computer is showing you how to do above this line is shaded and above this line is shaded, but really you should only shade this one section because it's not going to be very clear when you're using a pencil what's half shaded and what's full shaded. If they're both less than, that works too. Less than means under the line, so we shaded under that line. This is less than as well, so we shade under that line. The part that's underneath both lines would get the dark shading. Here you can see it as this aquamarine kind of darker green color. So all this section in here would be considered a solution to the system of inequality. And then the last one we get to look at is your single variable ones. Remember, if it said y and a number, then you're starting on the y-axis. So they found 3 on the y-axis, computer graphed it. Because it said greater than, they're going above the line. So this section is shaded. But that's not the whole answer because I have a second condition. I have another line which says x has to be less than -2. So that's going to be a dashed line at -2 on the x-axis. So really the only part that works for both of them would be a coordinate point in this section. So you'd be shading this little section up here in the top. So as you go through your work this week, I'm going to be giving you graphs that are already done. I'm going to be giving you graphs that look more like these ones. And you're going to have to determine based on this graph which inequalities made it happen. So just by looking at the graph, I can see that both of these are shaded above this line and above this line. So I know I'm looking for greater than or equal to for both equations. So I'd be looking for a set of equations which both had this symbol on them, because I saw the shading was above both lines and I saw both lines were solid. So that's how you'll do it, and I wish you good success on this week's